Hey everyone, thanks so much for making it tonight. I know that the world's kind of crazy right now, so I'm glad that we can find the silver lining of coming together to talk about security and talk about a really, I believe, fascinating topic about serverless security and how to attack serverless functions. So I hope you will find that this presentation is rewarding for you as well. So, before we get into the presentation, I wanted to briefly plug the course that I teach for SANS, which is SEC 540, Cloud Security and DevOps Automation. Much of the material in this presentation comes directly from the course. If you're a security professional and are not well versed in the ways of DevOps, you are prescribing solutions for problems and teams that don't exist anymore. SEC 540 gives you the context and the practical skills to play in that space. The lab architecture is deployed on premises, in AWS and in Azure, giving you real-world examples of how to utilize these skills across multiple environments while learning core cloud concepts. For the more advanced students, there are a plethora of challenging tasks that you can tackle in NetWars, which runs throughout the week. Implement security controls in the cloud using the code that we provide, and you can copy and paste that code into your organization's infrastructure, and in the process, win this awesome challenge coin. Also, something that's brand new is we have a certification for the class called GWAPT Cloud Security Automation, or GCSA. If you'd like to learn more about it, go to sans.org/sec540, or feel free to reach out to me either on LinkedIn or on Twitter. And my Twitter handle is @BrandonMaxEvans. So a few details on me. My name is Brandon Evans. I come from a developer background originally. I've worked on a variety of teams that follow DevOps practices. Most recently, I worked on a product development team at Asurion that was primarily based in AWS. I worked on a lot of cool things for Asurion, who allows me to also do stuff for SANS. So I'm very thankful to Asurion for allowing me to have these multiple opportunities. But at some point, I determined that I like breaking things much more than I like building them. So I moved over to the security world. So as I mentioned, I'm also a SANS instructor. My day job is Asurion. Most people who teach for SANS don't do it full time, and I'm no exception. But I am a SANS instructor that has taken a variety of GX certifications. A couple of weeks ago, I took the beta exam for the GCSA, or GWAPT Cloud Security Automation, which is, once again, the certification for 540. Unfortunately, because it's a beta exam, I won't know my score until next month. But considering the fact that I teach the class, hopefully I did an all right job. Let's hope that I passed the certification. So before we dive deep into the details of serverless, I want to make sure that everyone is on the same page as to what serverless even is. There have been several meanings of this term. Historically, it's been used to refer to managed platform as a service backends that you can leverage in your application without maintaining the underlying infrastructure. Typically, developers would use these to create robust single-page applications or mobile applications while writing little or no backend source code. Here are some of the services that we would call serverless. One that I'd like to highlight is Firebase. If you aren't aware of what Firebase is, I strongly recommend that you read up on it. It is a very popular tool that allows you to connect to a central database directly from your front-end application. If that doesn't scare you, it should. I find that Firebase is oftentimes used for proof of concept applications, but when those applications go to production, teams struggle to untangle from it. There's another topic we can talk about on another day, but it's a serverless technology that you should be aware of. Other services that are considered serverless are Auth0 and AWS Cognito. These allow you to authenticate your users without running your own authentication server. So, more or less, the trend is that we're allowing developers to build applications while maintaining fewer and fewer servers. This brings us to the current meaning of serverless. At this point, developers have gone from running their code on premises to the cloud. They've integrated with various platforms, much of which we don't manage the infrastructure for. One example of this is I don't ever have to think about what type of EC2 instance my DynamoDB database is stored on. However, with this infrastructure, I still have to care about where my code is running. So what if we changed that? What if I could just write code, have it run in the cloud, and never worry about what server or container it's running on? That's where the new definition of serverless comes in. Using technologies like AWS Lambda and Microsoft Azure functions or Google Cloud functions, I can define events that trigger code to be run, and I can ensure that this code is run without maintaining any virtual machines or containers. I can make a function that executes when an API is called. I can have a serverless function that is called when a file is uploaded to an S3 bucket to do some kind of post-processing on, let's say, an image file. I can do all of this and much more. This allows me to focus on what I, as a developer, actually care about, which is writing code that solves a problem. So if you are a security person, you might have heard of serverless technologies, and your first impulse might be to think that this technology is too immature and that developers are reckless for adopting it. So I want to make my allegiance known right out of the gate. I love serverless, and you should too. I love it as a developer who wants to focus on writing code to solve a problem. I also love it as a person who never wants to wake up in the middle of the night to reboot a server. And believe it or not, I like it from a security perspective. Every security person should be happy about the fact that serverless shrinks our portion of the shared responsibility model. Serverless means that we don't have to patch our underlying virtual machines every Tuesday anymore. It also means we can restrict permissions much more granularly than we have been able to do so in the past. And at least theoretically, no long-running servers means that there are also no long-running command and control channels. Overall, I think as serverless matures, it will become the recommended practice from security teams. However, with any new technology, there are bound to be security concerns and misconceptions. In this technical demonstration, I will show that in fact, it's possible for you to gain shell access to a serverless server. So you might be wondering, serverless server, isn't that an oxymoron? First of all, who are you calling an oxymoron? Second, this is a very reasonable thing to think. Serverless is a misleading term. It does not mean that servers don't exist. It means that we don't care where our code is running. We just want to make sure that it runs on any arbitrary server. We don't manage the servers ourselves. So despite the fact that we don't manage the servers, I'm going to show you that it's possible to gain shell access on these underlying servers and execute arbitrary shell commands nonetheless. Now, don't worry too much. I'm not about to reveal that there is a secret SSH port open on these servers. That's not what this talk is about. So to understand this attack, we first have to review two types of vulnerabilities. The first is command injection. Injection is possible anytime that an application takes data from a user and sends it to a subsystem. Unless you're careful, a hacker could trick the subsystem into executing the user-provided data as code. And there are many examples of injection attacks. Perhaps the most famous one is SQL injection, but there's also cross-site scripting. Cross-site scripting is another very poorly named term. It's really an HTML injection attack that may allow you to detonate JavaScript arbitrarily, but it's also a form of injection. The attack that we're discussing today is a command injection, where an application has a flaw that takes user input and interprets it as actual shell code. Luckily, shell command injection is becoming less and less common. I don't see these kinds of vulnerabilities in functions because developers rarely need to spin up a bash program to get their workload done in this day and age. However, there is another much more likely way to get shell on a serverless server, and that is a supply chain attack. I've heard a statistic recently that states that in Node.js, in their ecosystem, 97% of the code you deploy comes from open source libraries and frameworks. So that begs the question, what are the odds that one of these open source libraries gets compromised? Unfortunately, the answer is 100%, because this has already happened with a popular NPM package called ESLint. ESLint is a very simple program. It just looks for issues with your code, style issues or syntax issues with your code. But the hacker changed the functionality of ESLint to download arbitrary code from pastebin.com and execute it. And the one piece of code that we're aware of that the person executed was code that stole npm.js.org tokens, which allowed that person to compromise other repositories, which resulted in a huge outage because npm.js.org had to revoke all these tokens. So this shows that any component you install is a potential vulnerability. And if that component secretly starts executing commands on your server, lots of bad things can happen. For this reason, we should perform what is called component analysis. This is where we use tools to automatically scan our dependencies for known vulnerabilities. This is an important tool in our toolbox, but far from a perfect solution. These tools will not save us from a zero-day vulnerability. Now, one of the critical components of compromising a system is persistence. You might be thinking, based on the description that I gave before, that serverless is ephemeral. And for that reason, after each function invocation, you will get a brand new container in which to execute, which means that you would not have long-term persistence. Unfortunately, this is only partially true. In reality, you can only get a new container when your function goes through what is called a cold start. Cold starts occur the first time you run a function in a while, or when you have enough traffic to result in concurrent executions. Although the details around cold starts are mostly unknown because the providers of these services don't advertise all of their internals, many folks have done research on this subject. It turns out that the cold start adds a tremendous amount of latency and that warm environments, quote unquote warm environments, run much faster. Developers know this all too well. And in order to avoid taking a performance hit, they will oftentimes purposefully keep their functions warm. In fact, there is a plugin for the serverless framework, a very popular framework for deploying serverless functions, called Serverless Plugin Warmup, that will invoke your function every 5 minutes by default in order to keep your function warm. You might be thinking that this defeats the purpose of the serverless model. And you know what? I'd probably agree with you. However, at this time, the pricing model for Lambda is so much better than EC2 in most cases that some teams would rather use Lambda incorrectly to save money. This would be all well and good if it weren't for the security implications. If a developer or hacker keeps the runtime alive, it is even easier to persist your attack. So now that you understand the attack vector, we are going to shift the conversation away from these details and onto the risk associated with these attacks. In the remainder of this presentation, we are going to simulate the process of compromising a serverless server with a new tool called Puma Security Serverless Prey. This is a suite of functions and tools that we can use to establish reverse TCP shell connections to all 3 of the major serverless function providers. This was created in partnership with another SANS instructor, Eric Johnson, who is also the lead author of SEC 540 and a co-author of SEC 510, which, by the way, I forgot to mention earlier, is a course that I'm working on that covers a lot of this material. So this project is sponsored by Eric's company, Puma Security. So we have named each function after a big cat of prey. So we have one for Lambda, which is our Panther function. We have one for Azure functions, which is the Cougar function, and one for the Google Cloud functions, which is Cheetah. So you can type this URL or scan this QR code in order to get access to the malicious functions and our associated research. You can take a picture of this now, or you can wait till the end. We're going to show it off again at the very end. So let me give you an overview of what serverless prey is and what it does. So the first thing you have to do is you have to upload the function itself to our cloud provider of choice. So that can be AWS Lambda, it can be Azure functions, or Google Cloud functions. So I've already done that process in the background. I'm going to be demonstrating the remainder of the steps. Next, the attacker, in this case, I will be the attacker and the victim, will open a Netcat server on my personal machine. So for those who haven't used Netcat before, it's a simple way of sending data back and forth between 2 machines via the command line. In this setup, we are going to have our functions connect to the Netcat server on the attacker's machine, in this case, my laptop. So my laptop doesn't allow inbound connections from the internet into any port. That would be a good thing to prevent from happening from a security perspective. So we are going to use a service called ngrok, which exposes the netcat listener to the public internet on a random port that ngrok server, one of the ngrok servers selects. Next, we will invoke the function with the connection details from ngrok. This will result in the function taking those details, connecting to the netcat server via ngrok, and then listen for commands to run. We're going to type our commands into the CLI, which will be supplied over the internet via the netcat server that the function phoned home to. So TLDR, serverless prey, is basically SSH daemon for cloud functions. This is obviously a simplification, but it gives you an idea of what we are going for. We want these functions to be accessible to run commands from our computer. So that's what I'm going to hopefully be able to demonstrate to you in the remainder of this presentation. So without further ado, it's demo time. So I have 7 different tabs here. I'm going to be exploiting AWS. I'm going to be exploiting Azure. I'm going to be exploiting Google, and I'm going to show you what damage can be done once we are into the function. So for starters, I'm going to run this handy script in order to automatically execute the steps 2 through 5 that I showed in that slide earlier. So here goes nothing. So that prompt implies that I am now in the AWS Lambda container. Let's type ID to see what user I ended up being. Okay, so at this point, I know that we're in the actual server. So you're going to notice this shortly, but approximately every 30 seconds, we will get a message saying reconnecting. And there's an important reason for this. Functions do not run for that long. And if they're backed by API gateway, you have a maximum timeout of 30 seconds. So every 30 seconds, the connection is going to be terminated, and our command is smart enough to automatically reconnect to the server. So from here, let's take a look at where we landed. So PWD, or print working directory. So we're in the var task directory. I wonder what's in there. Let's type ls. So we can see 2 different files in this directory. So first, let's see what's in the handler.js file. It turns out this is the actual source code for our Lambda. So this code is the Panther code that I advertised earlier. So this is, not particularly exciting. But imagine if this was a real function. There's a lot of implications to what you get from this. You get intellectual property if you're hacking a particular corporation. You get potentially secrets if there are secrets hard-coded in the application code. And you can also learn about how the application works in order to execute other attacks. So that's not great. Let's take a look at that other file, config.js or JSON. So we actually have a configuration file here that contains credentials for a database. So you might be thinking, okay, I understand that this is going to persist for a decent amount of time, but eventually I'm going to find the hacker and kick them out of our network, out of this function. Or I could just change the credentials or patch the system and let the credentials automatically rotate because this Lambda is using an IAM role and those permissions are temporary. But what's not temporary? This password right here is never going to change unless you manually rotate the database password, which, let's be honest, doesn't happen very often. So even if you get kicked out of the function, you can get credentials that live much longer. So let's try a different type of attack. Next, I'm going to try to store some kind of shell script on this container to persist some kind of malware. And I'm going to make this really simple. I'm going to make it a script that just says the word hacked whenever you execute it. So I'm going to let it restart real quick, and then I'm going to type out the message. So I don't want to be interrupted in the middle of typing. Okay, here we go. Echo, hacked, home malware.sh. Let's try writing to a file called home malware.sh with these contents. Unfortunately, with AWS Lambda, I am thwarted from this attack. And the reason why that is that the vast majority of this container is read-only. However, there is one big exception, and that's the temp directory. They give you that directory to work in order to, for perhaps, process a file like that example I gave you earlier with S3. So let's try writing to the temp directory instead. And you won't see it right now, but it's working. So if I make this an executable and I type here, it's going to actually run that script. So that's particularly worrisome. So I wonder if this file is going to persist after that restart. So let's ls temp. It turns out that file is existing for multiple invocations of this function. And this is all about that cold start, warm start thing. It's going to reuse the container until the function is inactive and then retire the warm environment. And then the next time you execute it, you'll get a new cold start. But I'm keeping this function alive every single time that I'm restarting my connection. So this malware is going to persist for quite some time. Okay, that's a couple things we can do to this container. Let's take a look at the environment variables here. So there's quite a bit that's exposed right here in the environment variables. You get a lot of data on the project, you get a lot of data on the ecosystem, but what's most interesting are these tokens. I'm gonna zero in on those tokens. So we have a couple different credentials that are being used by the container in order to authenticate itself to other services. So the Lambda needs to access various other AWS services. These three credentials are the keys necessary in order to actually access those resources. So at this point, I can actually exit out of the function. I don't need to be in the function anymore. From here, I'm going to demonstrate that we can take these credentials and we can use them to access things that we otherwise would not have access to. So from here, I'm going to transport to this terminal right here. So the first thing that I want to demonstrate is that I don't have anything up my sleeves. I am in an empty directory right now. I'm going to ls in the downloads directory. There's nothing here. But I'm going to show you that we can download things from S3 that we shouldn't have access to into this directory. So first, I'm going to start out with empty credentials. So now I have no credentials associated with this session, and I'm going to try to download the contents of this bucket that I set up, Panther dash and then some unique identifier. I'm going to try that out, and I'm going to get a message that says that there's an error. I tried to download this using a request that had a malformed authorization header. It wasn't able to build the authorization header out of these credentials. So what if instead I took the credentials that I got in the previous step and I set them in this terminal session? So let's take a look. So I just copied and pasted all of those credentials and I put an export up front. Now, let me try to get the same contents. And it worked. Now I can look at the secret file located at assets/Panther. Now, in this case, it's just a Panther. However, imagine the implication here. Imagine what would happen if this file was actually sensitive. What if it was a W-2 form? What if it was a credit card number? You could get a lot of things by accessing S3 buckets that aren't supposed to be public. And if your Lambda has access to those private buckets, an attacker who gets to compromise the Lambda will be in the same position. So now that we're authenticated, we can do some other things. We can also get some credentials from the parameter store or AWS SSM. So here I'm going to try to get the database user from the SSM service. And it turns out that I'm able to do so. And I have the value right here, but it's encrypted because this is a secure string. So the same thing is true for this password parameter that I can get here. I'm not able to look at the contents of the secret unless I'm authorized to decrypt the secret using KMS. So I'm going to try to decrypt the password with using this flag with decryption. So if I have permissions to decrypt the secret, I will be able to see it in plain text. And there we go. This is the actual password. And if you don't believe me, I'm going to do this with the username, and you should see Panther underscore username or underscore user. Or is it? It's just slash user. My apologies. Whoops. With decryption slash user. There we go. Panther user is the unencrypted string. So we can not only get secrets, but also decrypt them. So that's it for AWS. Let's move on to Google. So we're going to use the Cheetah function this time. The cold start is pretty painful, isn't it? So from here, let's see what user we're running as. It turns out that in the Google Cloud Functions platform, by default, you are actually running as root. And this is very problematic if you know things about container security. Basically, if there was a container breakout vulnerability and the contents of this function could access the host system, it would be able to do so with the root user. They would basically get host root, which is very problematic. And there was a container breakout vulnerability just in February of 2019. So these things do happen. So not a great thing to do. I hope Google changes this to be a non-privileged user. In any case, let's see what directory we're in. In this case, we are in /server or /srv/files. Let's take a look at what we have here. We have a couple different files. Let's focus first on cheetah.go. This is the Go function associated with Cheetah. So if I didn't mention this earlier, Node.js is used for Panther on AWS. Golang is used on Cheetah for Google. So here is the contents of our function. Again, it's not particularly problematic because this code is open source, but imagine if this was your company's code. You would really not like a hacker to get access to it. Again, we can get secret files as well. So cheetah.yaml has various credentials that are used for the application as well, which is not great. So the next thing we're going to try to do is we're going to try to persist malware. So I'm going to first try to persist malware in this directory. So once again, not all of this container is writable. Only a portion of it is actually writable. Unfortunately, for Google, a lot more is writable than a single directory. And we can see that by trying to write to the home directory. And then we're going to try to make it executable. And then we're going to try to execute it. Once again, we were able to execute an arbitrary shell script on this container. And in this case, we were able to persist it into a directory. And as far as I can tell, we can persist that to any directory other than the source directory. And that makes sense. You should never have a function that rewrites itself. That could lead to some instability, but that is highly problematic nonetheless. So let's type env to look at some environment variables. It turns out that there are a lot of details that are provided in the environment variables. Details about how long we have until the function times out. In this case, we have 60 seconds as opposed to API Gateway's 30. The amount of memory we're using, a lot of details about my project, a lot of things that we really don't want to expose. But fortunately, unlike with AWS, they are not exposing your system, your service account credentials in this environment variable. You have to do a little bit more work to get the service account credentials. So to do this, we have to talk to the Google metadata service, which you can find here. And this is basically a folder system. So we can go from / to / compute metadata. And we can go further and further into the metadata service. So we can go look at details on the instance shortly. So compute metadata v1. Oh, it's very important that you have a / at the end of your directories. It's very temperamental. So we from here can get the instance data. Whoops. And that's one tricky thing about whenever you have a restart. Oh, it actually worked that time. That's awesome. It reconvened from where I left off. I'm kind of surprised that worked. I'm gonna have to look into why that is. So we can go deeper and deeper and eventually get to this directory, the scopes directory. So this basically says all of the different services that we can interact with. By default, the function gets the execution role of editor. And it's important to understand what editor allows you to do. Basically everything for the services that are in scope for your user. It has all of the permissions of the viewer role, plus it can modify resources. This is the second most powerful role. The only more powerful primitive role, owner, gives you the same permissions that an editor gets, plus it can manage permissions and set up billing. Google's official documentation says that you can change the service account to limit or extend these permissions. But if you decide that your Google Cloud function needs the ability to manage your account's billing, I'm not really sure what to say to you. In any case, we have the editor role in all of these scopes, including Cloud Platform. So basically, we can do anything we want in this account using the service account credentials. So now let's actually get those service account credentials from the metadata service. Oh, one thing that you can't do is use JQ because JQ is not installed here. So we're not gonna be able to see it pretty printed, but here is the token. So here's the token, here's when it expires. So in this many seconds. So it might expire in the middle of this demo, but we'll see what damage we can do in the meantime. So I'm gonna once again exit from here, and I'm going to take these credentials and bring them with me to my next session where I'm going to try to do things with Google on my host machine. So here is a URL that I can query to get access to Google's cloud storage. I'm going to try to do that first. And by default, it's going to say this is an anonymous caller. You're using an anonymous caller and you can't access this project, which is reasonable. I made this bucket a private bucket. So in order to change this, I'm going to export a Google token environment variable, and I'm going to paste the contents that I retrieved in the previous session. And then I'm going to try to query this bucket or this account with these credentials. And now I can list all of the buckets in this account. It turns out that there is a bucket for the deployment, and there's also this evil bucket that I have for other reasons. And I believe somewhere here is the assets bucket. So I think this is the deployment bucket, and this might actually be the assets bucket. So this is some metadata about the account. It's not really getting us the information that we actually care about, which is the secret files. But let's zoom into the bucket and get information on what files exist. So here we can see we have a cheetah.jpg file that we can download from this bucket. So I'm going to take my authenticated call and I'm going to specifically download that object. And let's hope it worked. I'm going to ls. We can see that there's a Cheetah file here. Let's try to open it. And there's our Cheetah. Again, pretend that this is an actually sensitive file. Moving forward, we can also interact with the Google Cloud Secret Manager, which is a beta service, but I mean, basically everything Google provides on their cloud platform is considered in beta. And I understand that's because they want to try to make things better and better, but sometimes it means that they want to send out functionality that is not fully baked. And I think the Secret Manager, at least when it comes to automating the Secret Manager, I've kind of felt that way about the Secret Manager. But let's try to list all the secrets in this account. So we can see that there's a database password in here. So let's look at the metadata surrounding that password. So we're gonna get the latest version of the password. And this is just metadata. If we want to actually look at the contents of the secret, we have to do this access command. And you don't necessarily have permission to access a secret if you can list the metadata. So let's prove that out. Okay, so here we have our data, but it is actually base 64 encoded data. Now, if you know anything about encryption, hopefully you will immediately say, that's not encryption, that's encoding. Anyone in the world can reverse this string, and you're absolutely right. So let me demonstrate that. And now I have the plain text password, the same one that I got from Panther. So that shows that we can get secrets and images from the Google Cloud Platform. Now let's move on to Azure. So Azure is pretty interesting in that you have two different environments for Azure. You have Azure Linux and you also have Azure Windows. Or in some cases, you have nothing, because yesterday when I was practicing this demonstration, there was actually a service unavailable error message that I was getting. So, buyer beware when it comes to these less mature serverless applications. Or honestly, just buyer beware when it comes to serverless in general. This is still a very much new technology, and it's going to get better and better with time. So let's go into the Linux container first for Cougar. Let's type ID. And this is really interesting. I have a root user for Azure, and that wasn't the case last month. I don't really know what happened. Eric and I are scratching our heads right now. The only change that we made that we think could potentially be relevant is we changed the app service plan SKU from dynamic to basic. And if you unknowingly lose security when you change your billing, that's really bad. So I don't know if this was an intentional change or if it was a matter of I changed my service plan, but this was not a root user 2 months ago when I last presented this. So let's see what directory we're in. We're in the root directory. So we can see a lot of different files in here. Let's focus in on this directory, the www root folder. So this is a C# function. So it's actually compiled down into a binary. So if I look at /bin/*cougar*, I can see the files necessary to run this application externally. But I don't necessarily have the ability to read the source code unless I use a decompiling tool. Additionally, there's still a secrets file here. If I go to the app settings file in this directory, we can find some secrets associated with this application. So that's also problematic. We also can look at this ASP.NET folder, which interestingly enough has some data protection keys. I'm not someone who works that much in .NET, so I'm not positive what this file does, but the file makes it very clear that I should not share the contents of it, so I won't today at least. There are some examples of the mock data that you could get on our repository in our research section. So now let's try to persist some malware in this container. So I'm going to first try to persist it to the www root folder. And interestingly enough, based on my notes at least, this is going to silently fail. So let me try to execute it or try to show the contents of it more likely. And I don't see any contents. And if I ls that directory now, or just the directory, yeah, that file's not there. So it silently failed. It didn't give me an error message. But I can write to the home directory and execute it here. I didn't even have to make it an executable, interestingly enough. So I'm not really sure why, but that's pretty scary stuff that I can just persist malware just with a cat command and forwarding the output, or an echo command and forwarding it to a file. So for whatever reason, it seems like Azure functions live for a really, really long time, and I don't get that resetting that I get in the other two environments. So let me demonstrate that this file exists across sessions by Control-C'ing, and then creating a brand new session with Cougar. So home malware.sh, it's still there. Not good stuff. So we can look at the environment variables. Here there's a lot of data, a lot of keys, a lot of seemingly secrets. So that's scary stuff. But let's focus mostly on this MSI secret, because we can use that to look at the metadata service for Azure. So let's go to that metadata service and use it to generate a token for the storage service. So one good thing about Azure is that when you get the credentials are for a particular service or a particular scope. You can't generate credentials that work for every service. So here I'm going to get them for storage. For whatever reason, I have to type echo almost every time that I run this command to get the results. But here's the token for storage. And now I'm going to run the same thing for the Vault, which is their secrets manager solution. So now I have the credentials for both of those services. So I'm going to copy that into my notes. I'm going to leave this and go to my local machine once more. So from here, I'm going to demonstrate that if I make this request to the storage service with an empty bearer token, I will get an error. Let's see. Looks like I got something different than I expected. Let's see. Okay, that is, oh, this URL is malformed. It has assets in 2 different places. So, whoops, my notes have an issue. My bad. So if I remove that, this will say the authentication failed because the authentication information is invalid. So I have to change that authentication header. Okay, so I'm going to take the token that I got from the storage service before, and I'm going to export that value. Okay, and now I'm going to run the same thing. And here we're going to get some metadata on these containers. Unfortunately, they use XML, they don't use JSON, so it's a little bit harder to parse, but I can use this tool called XMLint to parse the contents. So you can see here we have a blob in this container called cougar.jpg. Okay, so from here we can download the actual image itself. So I'm going to do that here. I'm going to download the Cougar file to cougar.jpg. Okay, it's here. Let's hope that this worked. And success, here's our Cougar. Okay, just a few more things and then we'll wrap up the demonstration. I'm now going to try to get a secret from the vault. So, or list the secrets in this case. But this is an invalid audience error because we have created a token. The token that we exported was the one for storage, not for vault. And this demonstrates that you need to use the correct token for the correct operation. So let me instead use the token that I got in the second command for the vault. So I'm going to export bearer token, paste this second token, and try running it now. And now we can see all these secrets. We don't actually have the values, but we can see the secrets themselves. And now I'm going to specifically get the database password as shown here. And here's the content of that password. Awesome, or scary, depending on your perspective. The last thing I'm going to demonstrate is that we can actually get a command.exe shell session to the Windows Azure functions. So the Azure functions that are hosted in a Windows environment, we can run command.exe, which is interesting. You will have functions that you're going to eventually hack if you're doing penetration testing that are using the Windows platform. So it's important to know how to do this. And Serverless Prey gives you the tools necessary to simulate these kinds of attacks. So first, I can type this to determine what my user is. So I'm this work group user. I'm going to type pwd to see where I am. I'm in this directory right here. I can look at the contents of this directory. So here are all of the DLLs for our function. We can get the same types of details from this container as we did with the Linux container. So this is the same thing as cat is on Linux. So we're going to get the contents of this app settings JSON file, and it once again has this database password. We can also list the binary files for Cougar as shown before. So here's the DLL and the PDB. And we can also look at all of these fancy ASP.NET data protection keys. There it goes, just took a little bit. There it is, there's the key. We can persist malware, in this case in a batch file, if we so chose to. So if I dir/home malware.bat, there it is. And we can use set to look at the environment variables. So that's cool, but let's say you are more interested in using PowerShell because you haven't used command exe in a while. Well, you can actually pivot from here to use PowerShell.exe just by typing PowerShell.exe. And now we're in a Windows PowerShell session. So from here, we could do some damage as a PowerShell user. I'm not tremendously good at PowerShell, so I don't have a lot of good demonstrations to show to you, but that's the idea. So we have compromised 4 functions, one on AWS Lambda, one on Azure Functions, or 2 on Azure Functions, one for Linux and one for Windows, and then our Google Cloud Functions. So let's talk briefly about the remediation process. So there's no way to completely stop this vulnerability. We really can't prevent the attacks. The best thing we can do is minimize the damage that can be performed through this kind of attack. The number one thing you can do to do this is limit the permissions of your function's IAM execution role. If an attacker gets into your function, that's bad, and they can do what the function can do. But if that function has less permissions, that means the attacker also has lesser permissions. So in contrast, if the function has administrative access, that means compromising the function compromises your entire AWS account, which is very bad. And the same principle goes for Google and for Azure. We can also do some protections at the network level. We should not allow our functions to access resources over the network that it doesn't need to communicate with. And there's a lot of automation that we can use to audit our accounts for bad policies and bad configurations, find components with known vulnerabilities like we talked about earlier, and even block certain actions at runtime with runtime security solutions for serverless. We should use all of the tools at our disposal to limit the damage done here. Finally, detection is a must. Prevention is ideal. I know I got that phrase backwards, but prevention is ideal, detection is a must. And we need to focus a lot of energy on monitoring. These attacks are powerful, but they're also pretty noisy. If we can detect the attack, we can take actions to contain the damage and remove the attacker from the system. So you might be wondering, how can I do that? Unfortunately, this talk is mostly focused on the attack side of the spectrum. But here's the good news. The other author of this tool, Eric Johnson, and the author of Serverless Prey, as I mentioned, did a much longer talk on the defense of the functions at the RSA conference. So you can view that using this SANS URL or using that QR code. So if you want to learn more about the defense side, definitely check that out. Additionally, you should absolutely check out the course that I teach, SEC 540, Cloud Security and DevOps Automation. As mentioned before, a lot of this content comes directly from that course. So if you want to go into more depth, that course is a great asset to you. Additionally, when the course I'm currently working on, SEC 510, comes out, you should check it out as well, as it will cover similar topics to what we covered here. It's going to go into a lot of depth about all these metadata services, which is very important as metadata service attacks have been becoming very problematic, very famous. We all heard about the Capital One breach that happened last year, and it's not necessarily Capital One's fault specifically. That vulnerability affected a lot of different companies. So we need to understand those metadata services in order to protect ourselves. So I actually plan on giving a course preview webcast in a few weeks from now. So keep on the lookout for when we announce that webcast, and hopefully you can see a little bit about what we're going to cover. If you'd like to learn more about the differences between the big 3 cloud providers, I actually already did a webcast for SANS in January on that topic. You can find that at this URL or this QR code. And finally, please check out Serverless Prey. We put a lot of work into this project, and we mostly built it for some presentations, but we think it's very useful for serverless security awareness. It can demonstrate the risk of these types of attacks, which are only going to become more and more prevalent. So issues and pull requests are always welcome. So if you're interested in taking SEC 540, but you can't go to a conference due to the horrible virus that's going around the world, you can now take it as a Cybercast. So here are some of the upcoming dates for the Cybercast that you could take a look at. So what is a Cybercast? It's the same quality training that you've come to expect from SANS, just online. The same instructors who teach the class at conferences teach them on Cybercast. I myself will be teaching a Cybercast of Sec 540 at the end of May. This is an online live event and has the same lecture, lab, and NetWars experience as you would have in person. If you have the training budget and you want to learn more about cloud security and DevOps, I couldn't recommend 540 enough. And with that, let's look at some questions. So we got a couple here. So let's take a look at this. Give me one moment. What are the prerequisites for the Sec 540 course or the Sec 510 course? I'm not positive which one you're referring to, so I'll answer both. So Sec 540 doesn't have any formal prerequisites, but we have this new class, I believe it's Sec 488, which is an introduction to the cloud. So if you haven't been introduced to cloud concepts in general, that course might be better suited for you, but you can take 540 afterward if you'd like. Typically speaking, we oftentimes recommend that people check out Sec 545 if they're not used to infrastructure automation. So 540 is very much focused on the automation aspect, and it kind of skips over on purpose the GUIs that you can utilize, the graphical user interfaces that you could utilize in order to configure the cloud. So if you're not really comfortable with the idea of infrastructure as code, that might be a better prerequisite. So thanks for that question. Prerequisites for 510 are similar. 510, we'd recommend taking 488 first to get an introduction of cloud security, but after that, you can jump right into any of the 500 level security courses. Someone mentions that they can't see my screen. I really hope that other people could see my screen. So I'm sorry if you couldn't. Is there a way to enumerate what resources the credentials have access to? That's a really good question. I'm not positive for AWS, but we could see in the Google example that you could look at the different scopes that you have. And I believe there's a couple extra bits of metadata that you can get from the Google metadata service. And Azure, you have to specifically get a token for a particular service. So that's something that you have to consider as well. But I'm not sure about AWS. It's a great question. So when attacking serverless servers, are you attacking the AWS Azure GCP side of the, sorry, I'm trying to read the entire question. GCP side of the shared responsibility and not the customer side? Absolutely not. I am attacking the customer's side of the equation. This is not exploiting the underlying infrastructure or the, let's put it this way. I'm not attacking the Lambda service. I'm attacking the container that the Lambda service provisioned for me. And you know, it's kind of a gray area, but all of the ways that we can fix this attack come from the customer's side, right? All of these actions that I mentioned on this slide are things that the customer can do. A lot of it comes down to your code not having the vulnerability in the first place that allows me to execute commands on your server. So I guess there's a little bit of a gray area, but I would say it's more on the customer side. So what is Sec 510? Great question. It is a class on cloud security and analyzing cloud security. So the title is still a working title, but the general gist of it is we're going to really dive deep into the internals of these cloud providers to understand how they actually work underneath the hood and not just assume that the documentation provided by the cloud providers is accurate. We're actually going to validate that some of the things that the cloud providers put in their documentation is not accurate. And we're going to demonstrate how that lapse in understanding could lead to a security vulnerability. The video, if fully recorded, hopefully it was fully recorded, will be included at the end of this presentation. Shortly after, they will archive both the slides and the video. Do you have any tips on the GCSA? I just signed up for Sec 540 and I have not taken it yet. So I think that certification is really really fair. I think it's right down to the material of the class. So if you are following the material in the class, I think that you will succeed with the test. The class is very heavy into labs, which is great. It gives you a lot of firsthand knowledge of how to actually use the cloud. And that's kind of difficult for folks who have kind of pivoted into a more security or a more management kind of role, but it's so rewarding. And once you go through it, you'll get a lot out of the process. And I think once you've been able to practice those concepts, you will understand them well enough to take the certification. But there are many pieces of advice that I could give in general about GX certifications. It really comes down to your notes and your index. You need to have a lot of good notes to understand where all of your content is. You can look up the right section at the right time. So I got another question about what about artifacts? Any IOCs out there? IOC means a couple different things in a couple different contexts. Indicators of compromise. Okay, it's not an inversion of control. I always mix those two up. So indicators of compromise regarding artifacts, like in terms of script persistence, I would look at Eric's talk about that. I'm not super knowledgeable on the monitoring side. I'm doing more red team work in the context of this talk, but he went into a lot of details on how to detect the compromises. So there's a lot of details there that I'm not going to spoil, and I don't remember offhand well enough to explain. What ways can we monitor the AWS Lambda? I would highly recommend that talk. It provides a variety of tools that you could utilize. And yeah, no, it's definitely an area that's not being covered enough. And that's why Eric and I have been working on this subject. It's, really uncharted territory. I mean, serverless has really been getting popular maybe a couple years ago. It's getting serious adoption now. And like with any innovation in technology, security is oftentimes behind when it comes to creating tools that solve security problems with these new technologies. But with regards to monitoring, you can talk about monitoring your dependencies with dependency checking tools such as Sneak or not checkmarks, checkmarks is static analysis, Sneak or Black Duck or geez, I'm just blanking on a couple names. It'll come to me. I feel really bad because I have a friend who works for that company. The company does Nexus. Sorry that I'm blanking on the specifics. OWASP dependency check is a open source tool, so that's definitely a great place to get started. There are also a variety of tools that do runtime security, like PureSec or Protego or Twistlock, that actually prevents your functions from taking actions that it shouldn't be able to take. Thank you so much for mentioning Sonatype. I always mix up Sonatype and SonarQube, and I just wanted to make sure I got the name right. So yes, Sonatype is the company that I'm referring to. They also do dependency checking, and they're also the owners of Nexus and Maven Central. So thank you for that. So there's a lot of free tools. There's not a lot of free tools for runtime security. That's kind of like the next generation RASP technology, runtime application security protection. And there's not a lot of free tools there, but there are several vendors in that space. So Twistlock, Protego, and PureSec are a couple you can look at. And I believe PureSec has an open source version of their tool. It's just not the full-fledged commercial tool, which is cool. So what other tools did I mention that I may be able to give some insights for? Overly permissive policies. You can look at tools like Cloud Mapper or Cloud Custodian. So Cloud Mapper looks at your application, or Cloud Mapper looks at your infrastructure as it exists today and alerts you on vulnerabilities. Cloud Custodian prevents changes from going in that violate your policies. They actually revert changes, or can revert changes, I should say, that are made to your infrastructure that violate your policy. So that's a tool from Capital One. There's also CFN NAG, which is a CloudFormation linting tool or CloudFormation static analysis tool. So those are a couple tools at your disposal for solving these kinds of problems. And I don't see any new questions, and I believe we're at about time. So once again, thank you so much for making it out here. I know that the world is kind of a crazy place right now, and it's great that we can focus on ways to make our world more secure. I'm glad to be able to talk to you about this topic that I'm very passionate about. So if you'd like to learn more about this, or you have any other follow-up questions, please do message me on LinkedIn or on Twitter. Two more questions that came in right at the end. So one is the last tool that I mentioned. It's CFN, which stands for CloudFormation_nag. So it's going to nag you about policies that break your rules or break common understandings of best practice. And then there's an evaluation at the end for this webcast. I am actually not positive of the details of that evaluation. Carol, would you be able to jump in to fill us in about the eval?
Well, all I know is that I have the link in the chat window that they can copy and paste.
Awesome. So yes, we'd really appreciate feedback, constructive or positive. Either way is great. And if you have any questions about this kind of research or serverless prey, or you want to get involved with this project, you can message me on LinkedIn or Twitter, and I'd love to talk to you more about this because this is a really fun topic for me. But if there are no other questions, I think there's just one more set. Yeah, the static analysis tool was CFN-NAG. Awesome. Cool. So thank you so much for attending, and I hope you have a wonderful rest of your night or day, depending on where you are right now. So thank you so much for attending. Take care.